Hi Year 9s, in this video we're looking at a concept called completing the square. And so looking at this first example here, we've got a question, and I'll copy it out, x squared minus 8x minus 17 equals 0. And it's clearly a quadratic, so our strategy would be to factorize it. And so we'd be looking for two numbers that add to negative 8 and times to negative 17. But of course, 17 is a prime, and so it can only be 1 and 17, which clearly does not add to negative 8 in any way. And so completing the square is a strategy that we use when we have a quadratic that cannot be factorized. So it's a kind of an algorithm, and I'll show it with this problem, and then we'll look at the other problem. So we start by writing out one set of brackets squared, and we put the x into it. And so that when that bracket squares, it becomes x squared. And what we do is we halve this coefficient here. So we write minus 4, and we don't write x, we just write minus 4. Now, that negative 17 is still there, so is the equals 0, but we just have to think about what this thing is going to expand to. So x minus 4 squared, let's quickly expand it and see what we get. We get x squared minus 8x plus 16. So because we're saying this is turning into this, we've got x squared minus 8 there, but we've got this extra plus 16 that we don't really want. And so what we do is we write minus 16 afterwards, because that negates the effect of that plus 16. Okay, hopefully you get the idea of that. Rewind if you don't. So just simplifying here, that means we've got x minus 4 squared minus 33 equals 0. And so now we're going to solve it a little bit like a linear equation. So we'll add 33 to both sides, and that gives us x minus 4 squared equals 33. And then what we're going to do here is the opposite of squaring, which is taking the square root. And so we're going to take the square root of both sides, which just leaves us with x minus 4, and it's going to be equal to the square root of 33. Now, one thing we have to remember about square roots is they can be positive and negative, and that's what that symbol there means. So for instance, if you're looking at the square root of 9, that could be 3 times, that could be 3, because 3 times 3 equals 9. But the square root of 9 could also be negative 3, because negative 3 times negative 3 is also positive 9. So that's why we have that plus and minus there. Okay, so we haven't got x by itself yet, so we still need to add 4 to both sides. And so x equals 4 plus or minus the square root of 33. Now actually that's our answer, or I should say answers, because we can have x equals 4 plus the square root of 33, or x equals 4 minus the square root of 33. Now usually we just leave it with this here, but sometimes the question asks for an answer in decimals, and if that's the case you just have to use your calculator. And so we would just go 4, hang on, I'll bring it down so you can see it. We just go 4 plus the square root of 33, so we'd have 9.74, and for the other one we'd have minus 33, which is negative 1.74. So you can see these decimals are not very nice, and that's why this method is used when we cannot factorize a quadratic. And yeah, now that process is the same all the time, and you don't usually have to do this bit here. Just make sure you read the question to ask what it wants the answer in. But this is your method, and it is the same every time. So I'm going to go through one example in the next video, and then hopefully you'll be ready to try some of these yourself.